Hi everybody and welcome to Mastermind Math channel for grade 8 Sudanese curriculum. In this video I will try to explain the 10 theorems of circle. Let us start. Bismillah ar-Rahman ar-Rahim. Theorem 1. Let us see, all things, lines, angles, circle in blue, that means are given. So we have a circle, we have a center M, AB is a chord. Look at these signs. It means AC equals BC. That means C is a midpoint. So I have a circle with center M, I have a chord, and I have a midpoint. If I ask you to describe MC or CM, MC is a line segment. So the theorem says the line segment. So I'm talking about CM. The line segment. Which line segment? The line segment that joins the midpoint of the chord. Where? To the center of the circle. Okay, what happens for a line segment joining the midpoint of the chord to the center of the circle? This line segment is perpendicular to the chord. Is what? Perpendicular to the chord. So my result in red, it's perpendicular to the chord. So what happens? Then MC is perpendicular to AB. This is theorem 1. The line segment that joins the midpoint, the line segment that joins the midpoint of the chord to the center of the circle. This line segment, the line segment that joins the midpoint of the chord to the center of the circle, is perpendicular to the chord. This is theorem 1. Later on, when we come to prove the theorem, I'll just try to show you or give you a key that you will join AM using a ruler and BM. This is your construction later on, okay? Let us go to theorem 2. Theorem 2, here is a circle in blue. Here is AB, a chord also in blue. C is a point, it's not a midpoint, there is no any signs. And MC is a line segment. And this one in blue, this angle, the perpendicular, this angle is the 90 degrees. So it's also given, not like theorem 1. Okay, it's given. So let us try to describe MC. MC is what? Is a perpendicular. So the perpendicular, I'm talking about MC, the perpendicular drawn from the center of the circle, this perpendicular is drawn from the center of the circle to the chord. The perpendicular drawn from the center of the circle to the chord, what does it do? Bisects the chord. So what does it mean bisect? That means AC and BC supposed to be equal. So I will find that AC equals BC. This is my result here. So the perpendicular drawn from the center of the circle, this 90, the perpendicular drawn from the center of the circle to the chord. This perpendicular, this 90, it's drawn from the center of the circle to the chord. The perpendicular drawn from the center of the circle to the chord, what does it do? Bisects the chord. Theorem 3. Okay, this is a circle, and this is the center M. AM here is a radius. AM here is a radius. And okay, say AM. AM here is a radius. And BM here is also a radius. And say this letter is C. AC here is a chord. And BC here it's also a chord. Okay. Let us try to describe angle X and angle Y. Okay, angle X is called a central angle. Why? Because the vertex lies on the center and the arms AM and BM are radii. So this is called a central angle. So angle X is a central angle. Let us look at angle Y. The vertex, the corner, lies on the circumference. and AC, this arm is a chord, and BC, this arm is a chord. So what kind of angle is this? This is a circumference angle. So we have a circle, we have a center, we have a central angle, and we have a circumference angle. From A till B, if we choose any letter here, say D, A, D, B, this is called arc. So this central angle and this circumference angle, if you look at them, this central angle here, this central angle is drawn or subtended by this arc, and this circumference angle, it's also subtended by the same arc. So when the central angle and the circumference angle share the same arc, the relation is the central angle is twice, is double, is 2 times the circumference angle. By other words, the circumference angle is half of the central angle. So since the central angle and the circumference angle, both of them are sharing the same arc, we will find that then the central angle, which is angle X, is double the circumference angle because they are subtended by the same arc. Okay, this is theorem 1, 2, and 3. Let us go to theorem 4. Okay, look at theorem 4 here. Okay, theorem 4. This is a circle. Angle X here is a circumference angle. You will ask me why? Because the vertex lies where is the vertex? It lies on the circumference, and this is a chord here. This arm here is a chord. Even this arm here is a chord. So this is a circumference angle. Okay, look at angle Y. Angle Y here is also a circumference angle because the vertex lies on the circumference, and this is a chord, this arm is a chord, and this arm here it's also a chord. So look at angle Z here. Where is the vertex? The vertex, the corner, lies on the circumference, and this arm here is a chord, and this arm here is a chord. So these 3 angles are circumference angles. If they are sharing the same arc, they are supposed to be equal. Look at angle X. Angle X here, it's on the arc ABC. Look at angle Y. Angle Y here, it's on the arc ABC. Look at angle Z here, it's also on the arc ABC. So these 3 circumference angles are sharing the same arc ABC. Since they are sharing the same arc, they are supposed to be equal. So angle X equals angle Y equals angle Z. It can be for 2 angles, 2 circumference angles, 3 or more. Okay, let us go to theorem 5. This is a circle. This is a center. AB, this line segment is a chord, but not any chord, since it's passing across the circle or passing through the center. This chord is a diameter. So I have a circle, I have a center, I have a diameter. This is a chord, okay? This is a chord. Here, if we say this letter is C, this is a chord, and BC is also a chord, and the vertex here is on the circumference. So this angle whose vertex lies on the circumference and the arms are chords, this is not any angle, this is called a circumference angle. If you look at this circumference angle, it's drawn exactly on a diameter. So theorem 5 says the circumference angle drawn on a diameter is a right angle. So I will find that angle X equals 90 degree. This is theorem 5. Let us go to theorem 6. Okay, look at theorem 6 here. I have a circle. Okay, I have how many points on, or how many vertices, how many corners on the circumference? A, B, C, and D. These four vertices, they all lie on the circumference of the circle, so the figure ABCD or DCBA or ADCB clockwise or anti-clockwise is called the cyclic quad. What do you know about the cyclic quad? In a cyclic quad, opposite angles are supplementary. What does it mean, supplementary? That means they add up to 180. If you look at angle X, it's opposite to angle Y. Opposite angles are what? Opposite angles are supplementary. That means angle X and angle Y together, they add to 180. That means angle X plus angle Y supposed to give us 180. Opposite angles are supplementary. Number one. Number two, I'm talking about Theorem 6. In a cyclic quad, opposite angles are supplementary. Not only these two, even this one and this one together, they add to 180. Opposite angles are supplementary. Number two, the exterior angle. The exterior angle, okay, this is the exterior angle here, angle Z. This is the exterior angle. Exterior angle is made by the extension of one side and original side. Original, extension, extension, original, original, extension. This is the exterior angle. Angle X for angle Z, angle X is the adjacent angle. And which angle is opposite to this adjacent angle? Angle Y. The theorem says the exterior angle equals the interior angle. Which one? This one or this one or this one? A or B or C? The exterior angle equals the interior angle which is opposite to the angle adjacent to it. So this interior is opposite to the angle which is the adjacent angle to the exterior. So my exterior angle, angle Z, equals angle Y. Angle Z equals angle Y, because the exterior angle equals the interior angle which is opposite to the angle adjacent to it. This is Theorem 6. Theorem 7. Theorem 7. Okay, let us look at Theorem 7 here. AB here, what is it? It's a tangent. And MC is a radius, and this point is called point of tangency or tangency point. So we have a tangent and we have a radius and a tangency point, or the end of the radius. Okay, Theorem 7 says the perpendicular. What does it mean, perpendicular? Perpendicular, that means 90 degree. It says the perpendicular. That means we have a 90. The perpendicular. Which perpendicular? The perpendicular, this 90. The perpendicular drawn on a radius. Where? At its end. What happens for a perpendicular? I'm talking about this angle. The perpendicular drawn, the perpendicular, I'm talking about this angle, the perpendicular drawn, the 90, the perpendicular drawn on a radius where at its end. What happens for a perpendicular drawn on a radius at its end? Touches the circle at one point. What happens for a perpendicular drawn on a radius at its end? The perpendicular drawn on a radius at its end touches the circle at one point. This is Theorem 7. Look at Theorem 8. It's like Theorem 7. Okay, Theorem 8 says the angle. Oh, there is an angle. The angle between the tangent and the radius. Do you agree that this is a tangent? And MC is a radius? The angle between the tangent and the radius at the tangency point or point of tangency, this angle here is a right angle. So this is my theorem. Theorem 8, the angle between the tangent and the radius at the tangency point or the point of tangency is a right angle. The first corollary. You can see I have here 3 different points. From this point C, I can just draw one tangent. It's not possible to draw another one. If you try, you will intersect, or you will cut, or you will pass through the circle. And look at B, it's just one tangent, and A, one tangent. The first corollary says from any point on the circumference of the circle, it's not possible to draw more than one tangent for that circle. Corollary number 2. It's similar to this theorem. Okay, let us try to understand it. Here, it was the perpendicular drawn on a radius. That means at the beginning we have a radius. Theorem 7. The perpendicular drawn on a radius. That means the radius is before the perpendicular. The perpendicular drawn on a radius at its end touches the circle at one point. Now, corollary number 2. Here, the perpendicular, it's not on a radius. Here, the perpendicular is on the tangent. Okay, so we have a 90 here. The perpendicular, this one. I'm talking about this one. The perpendicular drawn on a tangent. From the tangency point, this perpendicular drawn on a tangent from the tangency point passes through the center of the circle. So the difference between 7 and 8, 7 and the second corollary. In 7, the radius is before the tangent. That means the perpendicular is drawn on a radius, which is already before the tangent. So the perpendicular drawn on a radius at its end touches the circle at one point. Theorem, the second corollary, it says the perpendicular drawn on a tangent. That means the tangent is before the radius. The perpendicular drawn on a tangent at the tangency point passes through the center of the circle. This is the second corollary. Let us go to Theorem 9. Okay, here is Theorem 9. We can see a circle with center M. AB here is a tangent. AC is a tangent. Okay, what do you know about Theorem 9? It says if two tangents are drawn to a circle from a point outside it, what happens if two tangents are drawn to a circle from a point outside it? What happens? 3 things. Let us try to write them here. Number 1, number 2, and number 3. Number 1, the two tangents are equal. So AB is supposed to be equal to AC. So AB, the first tangent equals the second. AB equals AC or AC equals AB, doesn't matter. Number 1. Number 2, okay, these two are equal. Number 2, the line segment. Which line segment? I'm talking about AM, this line segment. The line segment that joins the center of the circle with the intersection point of the two tangents. This line segment, what does it do? Bisects the angle formed between them. Here, this angle BAC, it's formed between the two tangents. This line segment bisects it. That means this angle here, if you say it's x1, this angle here x1 equals this angle here x2. This is the idea. Number 1, the two tangents are equal. Number 2, these two angles are equal. So angle x1 equals angle x2. The line segment that joins the center of the circle with the intersection point of the two tangents. This line segment is like a knife. What does it do? Bisects the angle formed between them. So these two angles are equal. Number 3, the two tangents, I mean AB and AC, are opposite to equal angles where at the center of the circle. So if you say this is y1, this is here y2. So the two tangents AB and AC are opposite to equal angles where at the center of the circle. So angle y1 equals angle y2. So the two tangents are equal, AB and AC. These two angles are equal and these two angles are equal. The two tangents are opposite to equal angles at the center of the circle. Theorem 10, the last theorem. Okay. This line, what is it called? It's a tangent. Let us say A and B. And here C will be the tangency point. CD here, CD, what is it? It's like a chord. Okay, and CE here, what is it? It's also a chord. And DE is also a chord. Okay. Theorem 10 says the angle. Which angle? The angle between a tangent and a chord angle between a tangent and a chord, not any chord that passes through the tangency point. This chord passes through the tangency, and this chord passes through the tangency, but this one doesn't pass, so this one is not with us, okay? This chord here is not with us. The angle between a tangent and a chord, this is a tangent and this is a chord. Let us take this angle, for example. The angle between a tangent and a chord, say it's angle x1. The angle between a tangent and a chord equals to the circumference angle. Which circumference angle? That circumference angle which is opposite to this chord. The angle between a tangent and a chord equals to the circumference angle. Which one? Opposite to that chord. Where? On the alternate segment. Let us see how can we find the circumference angle. Let us just hold the two ends and follow them until we find the circumference angle. So here is it. So this is x2. This angle x1 equals angle x2. So angle x1 equals angle x2, because the angle between a tangent and a chord that passes through the tangency point equals to the circumference angle which is opposite to the chord on the alternate segment. Not only this angle is between a tangent and a chord, even this angle here. This angle here, look at this angle here, say it's y1 for simplification. This angle y1 is between a tangent and a chord. The angle between a tangent and a chord equals to the circumference angle. Which one? Opposite to that chord, way on the alternate segment. Which angle is opposite to this chord? Let us find it. This angle. So this angle y1 equals this angle here, y2. That means also angle y1 equals angle y2. And this is all what we know about the 10 theorems of the circle. And thank you until we meet another time on a new video, inshallah. See you.